All right, in this lesson, we're going to look at how to attack derivatives of inverse functions. But so we understand what we're doing, we're just going to make sure we all remember what an inverse function is to begin with. So I gave you what I think is a pretty easy pair of inverse functions to understand. So we have f of x here is 3x plus 2. And the way I read this is f inverse of x. And the understanding here is that these are opposites, right? So essentially you can think of it as inverse operations like plus or minus. These are inverse functions, so they're the opposites of each other. And let's see what we really mean by that. So let's plug in 2 to f. So plugging in a value to f means I multiply it by 3 and add 2 to it, and we'll plug in f of 2 will do. All right, so that spits out, we'd say f of 2 equals 3 times 2 is 6 is 8, right? Now, let's take that 8 and see what happens when we plug it into f inverse. So that means we're doing f inverse of 8. We do 8 minus 2 over 3. That's 6 over 3 is 2. Write that in red because that's what we started with. So the inverse function means that when I plug a value, say 8, into f inverse, it gives us our original input value from f, right? So plugging in 8, spitting out 2 means that when I plug 2 into f, it spits out 8. So that's not a very complicated idea, I don't think, but we're going to write it in a more abstract notation because this more abstract notation is going to allow us to get to our derivative shortcut. So what we just said is that if I take f of f inverse of x, if I plug what f inverse spits out into f, this spits x back out. Right, so they cancel each other out and I get what I started with back. That's my 2, right? If we want to tie it back to our numerical example. So this is true no matter what as long as the functions are inverse, no matter what the functions are, no matter what x is. This is called an identity. It just has to, it's a fact, right? And then here's what's cool about this notation is I can actually use this to discover my shortcut. So I'm going to take the derivative of both sides. So whatever I do to one side, I do to the other. And on the right-hand side, the derivative of x is 1. And on the left-hand side, notice I have a function within a function. So the derivative of my outside of f prime, inside stays the same now. So I'm going to write f inverse of x, but then times now f inverse prime of x. And that was chain rule that I just used. So there's a reason we're studying this right after we did chain rule. And then say I want to know what this f inverse prime is. So I want this shortcut for the derivative of an inverse. Well, I can just divide both sides by everything else, right? So I'm going to get 1 over f prime of f inverse of x on the right. And on the left is the derivative of my inverse function. So we've done all this work, and it's given us now a shortcut for finding the derivative of an inverse. So this is my rule, and this is what you can write down on your cheat sheet. But it really comes from our fact up here. So if you're going to memorize one thing, it's that when you take f of an inverse of f, it spits out x. And then notice we can figure out this rule using chain rule. And really, this rule all makes kind of sense, because notice what this is really saying is that the derivative of an inverse is a reciprocal of the derivative of f, right? And that makes sense because here is an example graphically of an f of x and its inverse. So that's actually a reflection. And notice the slope of f of x is rise over run, q over p. The slope of f inverse is rise over run, p over q. So our result makes sense in context, and here's where this rule comes from. Now let's do an example. So here, this is straight off of Delta Math, by the way. We're asked for f inverse of 3. And the first thing I would do is just write down the rule. And if you can't remember the rule, I would derive it, right? So I would start with my identity here and then use chain rule to get it if you can't remember it. But I'm just going to write it down because we have it in front of us. So f inverse prime of 3 is going to be equal to 1 over f prime of f inverse. So I just plug 3 into my rule. And now, notice we're not given this. So this value, we don't know. Okay, so we need to figure out what is f inverse of 3. Because we're not given f inverse in the table, right? Well, f inverse is the opposite of f of x, right? So here, I'm going to find the y value in the table. The x value that goes with that y value is f inverse of 3. So I'm going to be like 1 over f prime of 1, replacing f inverse of 3 with the value 1. And then I'm pretty much done, right? Because f prime of 1 is given to me in the table. It's going to be 1 over 7, negative 7. So there we go. There's my solution. So simple rule. Tough for me to memorize, though, so I like to make sure I understand how to derive it so that I don't have to remember it. I can figure it out when I need it. Now, on the next page, these rules go with the inverse rule in the sense that these are all inverses of trig functions. So we just studied trig functions. Arcsine of x, for example, is the same as sine inverse of x. So these just are two different notations that mean the same thing. So these are all the inverse trig functions. So arcsine is the opposite of sine. And we could, if we knew enough about trig, use this rule to figure out all of these individual rules. But we really don't. So somebody has done this work for us. We're just going to add these rules to our cheat sheet and work on memorizing them. So the way this works, right, is exactly like any other derivative rule. F prime in this case of x, we're using arctangent, would be 1 over 1 plus the inside squared times the derivative of the inside. So this again is a chain rule situation. So the derivative of that x to the 4th is 4x to the 3rd. And then this I would probably want to simplify just a little bit. 4x to the 3rd on top over 1 plus, and you know that you multiply the exponents here, x to the 8th. So again, we're using chain rule with all these. And now's a good time to also remind ourselves that the derivative is a limit. So when I see something like this, the limit of arcsine with h's in it, this is just a limit definition of a derivative. And we don't have to try to solve the limit if we know the shortcut, right? So the derivative of arcsine is 1 over square root of 1 minus x squared. So in this case, this limit is equal to 1 over the square root. We're going to use 1 minus x squared, but my x, in this case, is root 7 over 4. And then we can simplify that 1 over the square root of 1 minus 7 over 16. And then I could even simplify that further if I wanted. So again, the reason these go with our inverse function is they actually are derived from this rule that we just introduced. However, we're just going to work on memorizing these because the steps in between are a little trickier than we need them to be right now.